Indexing in the Tensor class allows selecting specific elements from the tensor, and we need to overload for this get item. Okay, we have self as the first argument. As the second we use index, and we can use the data type union, and it can be integer or slice or a list of integers, also tuple with the bunch of integers, or it can be numpy and the array, or the tensor itself. So I hope that this bunch of data types, it's everything that we need, and of course we return the tensor back. Just because we have so many options, we need to narrow them to the types that allows us to slice the data from the numpy array inside our tensor, from the data. Now we can check if is instance of the index is tensor or a numpy md array. We can convert them to the index like this: tensor data gate, and put the index right to the data gate, and we take the data from this data gate. It makes this index just only the numpy and the array, because in case if we work with the tensor as the index, we take the data from this tensor. So it means that then we can easily create an output variable and run self.data and take an index from the data. So we just perform an indexing operation for our data. Then let's create the dependencies list, and we need to check if self requires gradient, then we need to create the backward method. Let's copy this backward from the previous section. For the backward mode, we need to choose from the gradient only items at the indexed positions. So we can create the full gradient variable as numpy zeros like, and take the self.data as the original shape for our full gradient. It's a little bit tricky to apply the right indices to the full gradient, because for the index we can provide, for example, the same index twice or 3 times or as many times as we wanted. Yeah, for example, index 1, 1 and 1 in a list. We need to do the same in the backward mode. We need to apply the gradient value 3 times in a row. And we have the numpy add method that can help us with this. We can put the full gradient as the first argument, index as the second argument, and the gradient, it's what we need to add to the full gradient at the chosen index. It means that we add to this zero-like numpy array at the chosen index the gradient values. And the last step, we need to return this full gradient, yeah, after this numpy add at the chosen index. So I think that this will work fine. And then let's append to the dependencies leaf as the value. We use the self, and as the gradient function this underscore backward. So, and we return after this we return the tensor, and we use for the requires gradient self dot requires gradient. And for example, let's use this tensor A. We create the tensor B and take from the tensor A, let's say the items 0, 1, 1, 0 and 0, and print the tensor B. And you can see that we can take very easily the first row, then two times we take the second row and 2 times the first row again. So we can make this tricky slices. And let's run the backward and use the numpy once like B data. Okay, it works fine, and let's check the B gradient and A gradient. Okay, everything looks nice. Yeah, we just correctly identified the indices that we need to commit. And in this case, we chose the first row 3 times, and it means that we commit 3 times the gradient, yeah, for the first row, and only 2 times for the second row, yeah, and we commit 2 times the second row for the A gradient. The absolute value operation computes the magnitude of each element in a tensor, disregarding the sign. In other words, we just drop the sign for each element of a tensor, and the derivative of absolute value of the tensor x is on the screen. Yeah, it's just the sign function of x, and sign of x can be defined as the piecewise function. It equals 1 if x more than 0, minus 1 if x less than 0, and 0 if x is exactly 0. Now let's define the method ups inside the tensor class self, and we return just the tensor data type. Okay, first let's create the output variable and call numpy ups for the self.data. We just use ups for the forward mode from the numpy. We can copy these dependencies, and self requires gradient, it will be absolutely the same. Okay, good. And what we need to do in the backward mode, we need to return gradient times the numpy sign method applied to the self.data. So it's pretty straightforward for the backward mode, yeah? And then if we need to append to the dependencies list this as the value self, and as the gradient function this backward. Okay, and we return back the output self requires gradient and dependencies list. We can also leverage where to implement the ups method, and this approach removes the need for an explicit backward implementation since where already handles it internally. Here is a clean one-liner implementation. Okay, we need to return back the tensor where self more or equals to 0. In case if it falls under this condition, we need to return self, otherwise negative self. So, and it's absolutely the same implementation. It's just beautiful.